الله الرحمن الرحيم.
Solve the given initial value problem. So we have the second derivative of x with respect to t plus 9x equals 5 times the sine of 3t, where x of 0 is equal to 2 and x prime of 0 is equal to 0. So let's first rewrite this. We'll rewrite it as x double prime plus 9x equal to 5 times the sine of 3t. We'll just rewrite that to make it easier as we reuse it. So to solve this problem, we'll find a general solution x, which will consist of a complementary solution x sub c plus a particular solution x sub p. Now to find the complementary solution, what we'll do is we'll solve the homogeneous equation, x double prime plus 9x equal to 0, where we'll let x be equal to e to the mt, meaning x prime will be me to the mt, and x double prime will be m squared times e to the mt. Substituting those into this equation will give us m squared times e to the mt plus 9 times e to the mt, and that will be equal to 0. So if we factor e to the mt out of the left-hand side, the other factor will be m squared plus 9, and those two factors will multiply to give 0. Now e to the mt cannot be 0, meaning that m squared plus 9 will be 0, telling us that m squared will be negative 9, thus m will be the plus or minus square root of negative 9, meaning that m will be plus or minus 3i. So we'll have two solutions. M is 3i, or m is negative 3i. Well, if m is equal to 3i, then we'll have a solution which we'll call x sub 1, and that will be equal to e to the 3it. If m is equal to negative 3i, then we get a solution x sub 2 equal to e to the negative 3it. Well, if we have x sub 1 equal to e to the 3it, that means that x sub 1 will be the cosine of 3t plus I times the sine of 3t. And if x sub 2 is e to the minus 3it, that means that x sub 2 will be the cosine of negative 3t plus I times the sine of negative 3t. And because the cosine is an even function and the sine is an odd function, this will become the cosine of 3t minus I times the sine of 3t. And our complementary solution x sub c, this can be any linear combination of these functions, meaning that we can look at linear combinations of the cosine and the sine, telling us that we'll have something of the form c sub 1 times the cosine of 3t plus c sub 2 times the sine of 3t. So this is our complementary solution. So we've found our complementary solution, and our next step will be to find our particular solution, x sub p. So to do that, we'll have to come up with a proposed solution for this particular solution, and we'll use the following table. Now if we go to the table, we can see that we need something for g of x. Well, g of x, that's going to be this function 5 times the sine of 3t. In this case, it will be g of t. So the closest thing appears to be this sine of 4x, where of course we'll have the sine of 3t. So it appears we'll need something of this form, a times the cosine of 4x plus b times the sine of 4x, where of course 4x will be 3t. The issue, however, is that those functions will be in the form of the functions that are in the complementary solution. So what we'll do is, instead of using a times the cosine of 3t, we'll use at times the cosine of 3t. And instead of using b times the sine of 3t, we'll use bt times the sine of 3t. And so now what we'll need to do is we'll need to verify the a and the b using the given differential equation. So we'll need to find x double prime. So first we'll find x prime sub p. When we find that derivative, we can just use the product rule. We'll get a times the cosine of 3t minus 3at times the sine of 3t plus b times the sine of 3t plus 3bt times the cosine of 3t. And then x double prime sub p, we can easily verify that that will be negative 6a times the sine of 3t plus 6b times the cosine of 3t minus 9at times the cosine of 3t minus 9bt times the sine of 3t. And when we plug all this into the equation, x double prime plus 9x equals 5 times the sine of 3t, we'll wind up with negative 6a times the sine of 3t plus 6b times the cosine of 3t equal to 5 times the sine of 3t. And we can see that there are no terms involving the cosine on the right-hand side, which tells us that this term should be 0, meaning that b will be equal to 0. And so the terms involving the sine of 3t will have to be equal, meaning that negative 6a will be equal to 5, telling us that a will be negative 5/6. So our particular solution is going to be at times the cosine of 3t, so negative 5/6t times the cosine of 3t, and then we're going to add bt times the sine of 3t, but b is 0, so we won't add anything. So this is going to be our particular solution. And so now we can get our general solution x, which will be the complementary solution, c sub 1 times the cosine of 3t, plus c sub 2 times the sine of 3t, and then we'll add the particular solution, negative 5/6t times the cosine of 3t. And so our next step will be to find the constants c sub 1 and c sub 2, and we can use our initial conditions in order to find those. So we'll now use the general solution to help us to verify these conditions. So we first have x of 0 equal to 2. Well, that tells us that when t is equal to 0, x is equal to 2. So we'll replace x with 2, and we'll get c sub 1 times the cosine of 0 plus c sub 2 times the sine of 0 minus 5/6 times 0 times the cosine of 0. And what will happen here is we'll wind up getting 2 equal to, well, the cosine of 0 is 1, so we'll get c sub 1, and the sine of 0 is 0, this will be 0, so we see that c sub 1 is equal to 2. Then we have the condition x prime of 0 is equal to 0. Well, first we'll have to find x prime. Now we can easily verify that x prime, just using our product rule, we'll get, that's going to be negative 3 times c sub 1 times the sine of 3t plus 3c sub 2 times the cosine of 3t, and then we'll get minus 5/6 times the cosine of 3t plus 5/2 t times the sine of 3t. And so in this case, when t is equal to 0, x prime is equal to 0. So we'll substitute 0 for x prime, and we'll get negative 3c sub 1 times the sine of 0 plus 3c sub 2 times the cosine of 0 minus 5/6 times the cosine of 0 plus 5/2 times 0 times the sine of 0. And what will happen is we'll wind up with 0 equal to, well, this term will be 0 and this will be 0. So we'll simply get, well, the cosine of 0 is 1, so we'll get 3c sub 2 minus 5/6. And when we solve this for c sub 2, we'll find that c sub 2 will be 5/18. So now we can get our general solution. We'll have x equal to c sub 1, which we had found to be 2. So we'll get 2 times the cosine of 3t plus c sub 2, which we found to be 5/18. So we'll add 5/18 times the sine of 3t, and then we'll subtract 5/6t times the cosine of 3t. So this will be our final solution. So for this problem, we found a complementary solution as well as a particular solution, and then we added them together to get our general solution, and then we used the initial conditions to get the constants to get our final solution.